Let me try to tone it down a little bit. Okay. Excellent! The RC100 NVMe SSD and XS700 portable SSD are both powered by Toshiba's advanced 3D BICS flash memory, meaning you get solid-state speeds at an affordable price. The XS700 is a wicked fast external drive with USB 3.1 Gen 2 via a Type-C connector, and the RC100 may be small, but its M.2 NVMe interface means sequential read and write speeds at well over 1,000 megabytes per second. Click the sponsor link in the description to learn more. Okay, sorry about that guys, but in keeping with my video from last month where I built the fastest gaming computer that you can build, with the caveats being you're building a single GPU gaming system and you're mostly focused on gaming, not much else, I promised that I would follow that up with a faster gaming computer, and now we can do that. Fastest gaming graphics card at the time when I built this system originally was the RTX 2080 Ti, which had just launched. That is still the case. We are still using a single RTX 2080 Ti, but now we have an aftermarket version in our Asus ROG Strix RTX 2080 Ti. So get the fastest RTX 2080 Ti you can, overclock it as much as you can, and then combine it with the fastest gaming CPU. And although the i9-9900K, which has 8 cores and 16 threads, is not currently available, and I should point out a huge caveat here that I'm not encouraging anyone pre-order this until they can see the reviews, which should be coming out in just a few days, where we talk about performance and price to performance and the ridiculous overpriced costs right now because they're charging $580 for this if you pre-order at Newegg. Ignoring all that and just assuming, yes, you want the best of the best, the 9900K we can safely assume is going to be that. So I'm basically today going to be taking the system that I built last month, swapping out a few parts, swapping in the faster parts, and then I will follow this video up later on, since this is a build of the month, with some additional testing. That will be separate from my introductory launch day testing of this, which I am working on separately. Last thing I guess I should mention before we get started is the price. And this system, when we built it about a month ago, it's about $2,400-ish, and that's including a $1,200 RTX 2080 Ti, which was half of the price. This system I'm doing today is closer to $3,000, about $2,900 to $3,000, depending on when you buy the parts and some fluctuations and stuff. And I did want to point out where most of that money is coming from. The CPU is $200 more right now. Again, if you pre-order, it's $580, so that's the price I'm going with for now, as compared to about $380 for the 8700K. The motherboard I'm using is the Z390 Taichi Ultimate from ASRock, which is their highest end Z390 motherboard. This is a pretty nice board, but you can get by with something cheaper. For example, the board I used last month was more in the $180 range. The CPU cooler I'm using is the Cooler Master Master Liquid ML360R RGB, 360mm radiator with addressable RGB LEDs and everything, but it is also about $100 more than the 240mm radiator that I recommended for last month's build. And then finally, the graphics card is also about $100 more. Last month I used the price of $1,150. This month I'm using the price of $1,250 because again, you can't find these anywhere, and that's the rough price I'm assuming these Strix cards are actually going to be selling for once they are more readily available. So that's what's making the $500 price difference, going from about $2,400 to $2,900. Whether all that money is worth it is going to be up to you, the viewer at home. My job is just to build this system, so let's get started. Normally when I do a build, I kind of go over all the parts, and since I already built this system, I just really quickly want to point out what's different. Other than, of course, the all-in-one cooler, we got the motherboard, processor, memory, and graphics card. So our motherboard is the ASRock Z390 Taichi Ultimate. This is the highest end Z390 board that ASRock is coming out with, at least at launch right here. And as you can see, it's pretty much got a dark gray color scheme going on with some black accents here and there. It's got a little bit of a steampunk vibe going on with the gear design on their chipset heatsink. You might notice a couple Ultra M.2 slots right there below the CPU, so those are in decent locations. There's another one down here at the bottom that does have a heat spreader on it too. This is probably going to be your ideal location to start with. Then if you have more M.2s, you can add them there. Of course, your 9900K still only has 16 dedicated PCIe lanes going to all of your PCI Express connectivity down here, as well as your M.2 slots. So depending on your configuration, these are going to be split different ways at different times. That said, a few other features on the board that I do appreciate. Debug LED down there, so helping you out with some postcode readouts as you're getting started up. Surface mounted reset and power buttons are always nice to have, especially if you're doing an outside the box build. We have RGB support in the form of 3-pin 5-volt header as well as 4-pin 12-volt headers for the newer addressable style as well as the older non-addressable style. Our power delivery up here is supported by an 8-pin and a 4-pin supplemental CPU power connector, and it does look like we have some pretty beefy heat sinks on there. Since I am just doing a build here, I'm not going to speak to the performance of this power delivery setup, but it does seem like ASRock has put a decent amount of effort into that. Here's a look at the rear I/O, including some antenna connection points. Since we do have built-in 802.11 AC Wi-Fi, there is an external clear CMOS button there as well, which I also appreciate. We also have plenty of USB connectivity. There's two USB 3.0 headers there, as well as the newer USB 3.1 Gen 2 header beneath them. And then it looks like we have at least 7 fan connectors on the board. 1, 2, 3 up here at the top, 4 down here on the bottom right, 5 over here along the bottom edge, 6 up here next to the DIMM slots, and then, 8 total, I guess, 7, 8 over here on the left side. If I have an initial complaint about this motherboard, it's the I/O shield. I do wish that ASRock would upgrade these, at least for their highest end ones. This is still kind of the older single piece style, but hey, it's still functional enough. And then as for accessories, there's not a whole lot to speak of in here. They do include a rigid high bandwidth SLI bridge for 10 series GPUs, and then they do have an external antenna you can add in there as well. Beyond that, I've got my CPU, of course, here too, in case you guys wanted a quick closer look at it. It is an engineering sample, and it is in this package that has Paul's Hardware written on it, which makes me feel special. Thanks, Intel, for making this little package just for me. Also, I am going to swap in this memory kit, the Trident ZRGB, just because the kit I recommended in the build video was an RGB kit, so this will have it look the same. This is a 3200 speed kit, not a 3600 speed kit, but I'll see if I can maybe overclock it or something like that. And then, of course, lastly, our graphics card, the newly redesigned Asus RTX 2080 Ti ROG Strix version. And I already did a video where I tried this out with overclocking, so if you're interested, I will link that in the description. So check it out. All right, let's move on with the building process. All right, guys, this system has been reassembled, only required partial disassembly, and I think the only piece in here that I haven't actually shown you, unless you watched the original video last month, is the power supply, which is an EVGA 750 watt G3, which I am using the custom sleeve cable kit for EVGAs, so that is sold separately. Just please bear that in mind, these pretty black cables. Other than that, I wanted to point out that our fans there, which should honestly be acting as an intake because there is a dust filter over on this side for these 3 fans, I left in the orientation they are purely for aesthetic, so don't hate on me for that. When I do follow up and test the system, I'll flip those around so they're pulling air in rather than pushing air out. Right now we have very negative pressure in this case, which isn't an ideal scenario. And I also wanted to point out that with this motherboard, since we have the USB 3.1 Gen 2 plug, I was able to plug that in. So we're now fully maxed out on our front panel I/O there as well. I wish I could give you guys more information on the system, like actually testing it and everything, but I'm not allowed to do that quite yet. But you should stay tuned to my channel for when I am allowed to do that, because I will be following up with some benchmark tests on the 9900K very soon as I am allowed to share that with you guys. But of course, all the parts I used in today's build, the fastest gaming PC you can currently build within reason for a single GPU, are all listed down in the video's description. So check that out, hit the thumbs up button if you enjoyed this video. Thanks again for watching, guys, and we'll see you next time.